Right, here we are on note 6.1 part 2. A couple other BuzzMath problems that you have are ones that look like this. It says select the graph that shows the solution. So first you're going to want to solve it, right? Add 2 to both sides, and you get x is greater than or equal to 3. I don't have to flip this, right? Because x is on the left-hand side. We can read this. So I want something that's a closed circle, and I want it pointing to the left, right? So this is out because it's pointing to the, I already messed that up. Pointing to the right, my fault. So this is out because it's pointing to the left. So this is saying everything less than or equal to 3, not greater than or equal to 3. This is out because, number one, the solution's wrong. It's saying it's 1, which we already know it's 3. And it's also an open circle, so that's wrong. This is wrong because this is saying like the solutions only can exist between 3 and 1, and that's not true. This is saying any number equal to 3 or bigger than 3 is the solution, so that's wrong. And there you go. Here's your answer right here. There's your solution 3. It's got a closed circle, and it's any number equal to 3 or bigger than 3, 4, 5, 6, all bigger than 3 is part of the solution. And there you go. All right. Here, do we need to a rewrite flip would be a question you'll see a lot on your homework with the question mark, and the answer is no, because the variable is on the left-hand side again. So you just add 2 to both sides. And I get x is less than or equal to 11. So if I wanted to graph this is a rough graph, sorry. So there's 0. I go to negative 11. We'll just say it's about right there. I have a closed circle. Which way would I point? Point to the left. This is pointing to the left. Every number that is less than or equal to negative 11 is part of the solution. So negative 12. Remember, negatives, as you look like they get bigger, they're actually getting smaller. So negative 12 is smaller than 11. That works for the solution. Negative 13 is smaller than negative 11. That works for the solution. We can go on to infinity, right? All right, here it says match each inequality with its graph. So let's solve these off to the side. X minus 4 greater than 1, 1 plus x greater than or equal to 3, 4 plus x less than or equal to 4, and then x minus 3 less than 4. So this one, if I add 4 to both sides, you'll have x greater than 5. So you want open and right, an open circle pointed right here. If I add negative 1 to both sides, you'll have x is greater than or equal to 2. So you want closed and to the right. And here you'll have plus negative 4, that's 0. It's okay, you can get 0. So you have x is less than or equal to 0. So you want closed, and this time you want to the left. It's pointing left, right? Everything less than or equal to 0, that's left on the number line. And then add 3, so x is less than 7, so that's open, and that would also be to the left, everything less than 7 on the number line. So you're going to drag this. This one is the x minus 3 is less than 4, right? Because there's your 7 solution, open and left. This one is the 1 plus x is greater than or equal to 3, because your solution was 2 and it was a closed circle right. Here we have the x minus 4 is greater than 1 because it was an open circle, and obviously this last one is the 4 plus x less than or equal to 4. Now, a really good process of elimination, guys, is immediately go through and look at your signs. Anything like this, you're like, okay, it's got to be an open circle, so I will not choose either of those for anyone that, so like if you just in your head you're labeling, I gotta pick an open circle for this one, gotta pick an open circle for that one. That eliminates 2 answers right away. And the same for these. I gotta pick a closed for this one, and I gotta pick a closed for this one. And you can almost even do these without solving. This is like open and right. This is closed and right. This is closed and left. This is open and left. And you're just kind of looking at the graphs and say, okay, I got a closed circle pointed left. Okay, that's got to be this one. I got an open circle pointed right. Okay, that's got to be this one. I got a closed circle pointed right. All right, closed right. That's got to be this one. Open circle left. Oh, it's got to be that one, right? I didn't even have to solve them. I just looked at the circle and then looked at the graph and was like, okay, I got my solution. All right, last one. It says Elijah wants to save at least 100. So what does that mean? At least means I could do 100, but I could also save 101, 102, 103. Like, it wouldn't be the end of the world if I got bigger than that. So at least means, okay, I want to go greater than 100, right? Or equal to. So far he saved $35. So what inequality can represent the least amount Elijah needs to save to reach his goal? So if we want to make sure that it's at least 100, right? It's 35 plus some amount of money that you don't know yet, has to be greater than or equal to 100. Because if I get right at 100, which would be 65 in this case, I've got my goal. But if I save $66, I've still got my goal. I'm just 101. I've saved 101, and that's fine. That's not the end of the world if I save more money, right? So that at least there represents this greater than or equal to symbol, right? All right, go ahead and make sure you're doing buzz math.